We now want to talk about a method for solving quadratic equations called the quadratic formula. And the great thing about this is that this formula will always work. Okay, it's just what I call a plug and chug through, or plug and work through the formula, and it'll give you the solutions. Okay, so it goes like this: the solutions of a quadratic equation in general form. So it has to be in this form: ax squared plus bx plus c, and this is again where a does not equal 0, are given by the quadratic formula. So these are the solutions. Okay, so it's x is equal to negative b. So this, you're going to see that the a, b, and c are the coefficients of the x squared, the x, and then the constant term. So x is just equal to negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. And this formula works. So it works every time. Okay, so basically what's going on here is if you have any of the other methods that we've talked about in this class, if you can just put the quadratic equation into this general form, you could have just used this formula here. So let me give you a problem. And let's work a problem here to verify that this works. Okay, we're going to use this formula to solve. Okay, so let's solve this one here. So x squared plus 5x plus 6 is equal to 0. So we've actually worked this exact problem in a previous lecture. Let me go back. We actually solved it by factoring. So look, we solved by factoring. This was one of the first ones we did. And we saw that the answers are -3 and -2. So let's see if we get the same answers using this quadratic formula. Okay. So the way this formula works is x is equal to -b plus or minus. So this plus or minus means you have two solutions. One where you add and one where you subtract away the square root of b squared minus 4ac all over 2a. So look, what you have to figure out here is you have to figure out what a, b, and c are. So a is the value in front of the x squared. Well, there's nothing there, so it's a 1. It's a really invisible 1. B is this value here at the 5, and C is the 6. So what you're going to do is you're going to take all these values and you're just going to plug it in here and see what you get. So x is equal to minus b, so it's minus 5 plus or minus the square root of b squared, so that's 5 squared, minus 4 times a, which is 1, times c, which is 6, all over 2a, which is 2 times 1. All right, so let's work through this. This is minus 5, plus or minus. This is 25. Minus 4 times 1 times 6 is minus 24, so minus 24, all over 2. Well, let's clean this up. What's 25 minus 24? That's 1, so it's the square root of 1 over 2. Well, what's the square root of 1? I'm going to move it up over here. That's just 1. So x is equal to minus 5 plus or minus 1 over 2. So what you have to do now is you have to simplify this. You have to get the two solutions. So x could be equal to minus 5 minus 1 over 2, or x could be equal to minus 5 plus 1 over 2. Well, this is minus 6 over 2. Look, minus 3. That was one of the solutions we saw by factoring. This is minus 4 over 2, which is, oh, look at that. We get the same one. Boom. So this formula works. Okay, you could use this quadratic formula, and it'll work every time. Okay, which is great. All right. Sometimes it'll just be easier to solve by factoring. What I like to say is one of the things I would talk about would be how do you determine which method works best. I always find that factoring works the best. Like if it can factor, just solve by factoring. Okay, if it's missing this middle term here, there's no x, you're just going to use the square root property. I personally don't find the completing the square method that useful. I would much rather just jump right into the quadratic formula at that point. All right, let's try another one. Let's look at x squared minus 3x minus 2 is equal to 0. All right, let's try this. So we're going to solve using the quadratic formula. So a is equal to 1. My b is equal to minus 3. And my c is equal to minus 2. All right, so you're just going to go x is equal to negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So just going to plug it in and go. So x is equal to, so you have to be careful here. This is negative 3. So it's negative 3 plus or minus the square root of negative 3 squared minus 4 times 1 times minus 2, which is c, all over 2 times 1. So you're just going to have to clean this up. Negative becomes a positive. So this is 3 plus or minus the square root. Minus 3 squared is 9. Minus 4 times minus 1, or excuse me, minus 4 times 1 is minus 4. And minus 4 times minus 2 gives me plus 8. All over 2. So this is x is equal to 3 plus or minus the square root of 17 over 2. And notice what you cannot do here is you cannot simplify under the radical. So if you can, okay, going forward, if you can simplify under the radical, simplify under the radical. But we can't. So our two solutions are x is equal to 3 minus the square root of 17 over 2, or x is equal to 3 plus the square root of 17 over 2. All right, let's just do one last one here. So let's solve here. Let's look at 2x squared plus x plus 5 is equal to 0. So look, my a is 2, my b here is 1, and my c is 5. So x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So x is equal to minus 1 plus or minus the square root of 1 squared minus 4 times a, which is 2, times c here, which is 5, all over 2 times 2. So x is equal to minus 1 plus or minus, this ends up being the square root of 1 squared is 1, minus 4 times 2 is 8, 8 times 5 is 40, so minus 40 all over 2 times 2, which is 4. Well, 1 minus 40, oh, we got a negative number under the radical. Okay, that's okay. So it's minus 39 all over 4. You know, you can't break this up, obviously, right? Like, it's 13 times 3, so there's no perfect square in there. But what I do see is this negative can get factored out. I'm going to move it up here as the imaginary unit I. So I have two solutions here. Okay, x is equal to minus 1 minus the square root of 39i all over 4. Or my other solution is x is equal to minus 1 plus the square root of 39i all over 4. So this formula will work, you know, and generally when you get, you know, nice integer solutions here or solutions that are rational numbers, what you're going to notice here is that you could have solved by factoring, right? But when you get, you know, things that still involve a square root like this, you wouldn't have been able to solve by factoring. Okay, so one last thing I just want to quickly talk about is what's called the discriminant. All right, so we can find the solutions for a quadratic formula, quadratic equation of the form ax squared plus bx plus c equals 0 using this quadratic formula. Now what's underneath this radicals, this b squared minus 4ac, is called the discriminant, okay? And the discriminant is this quantity b squared minus 4ac, which appears under the radical sign. And the discriminant of the quadratic equation determines the number and type of solutions. Okay, so what I mean by here is if you were to just look at the value of b squared minus 4ac, if the discriminant is positive, there will be 2 unequal real solutions. If the discriminant is 0, there is 1 real repeated solution. Okay, just 1 real solution. And if the discriminant is negative, there are 2 imaginary solutions. Like, look, if you go back here, what underneath the radical here was 39. What we saw here is we got two solutions, which was minus 39. We saw we got two imaginary solutions. What was underneath the radical here was positive, was 17. What we see is we got two solutions that are real numbers. So just one quick example. So let's compute the discriminant, then determine the number and type of solutions for this. So if you have x squared, 2x squared minus 7x minus 4 is equal to 0. So just remember, this is my A, this is my B, and this is my C. So if you were to take b squared minus 4ac, so it'd be minus 7 squared minus 4 times 2 times c, which is minus 4. You'd end up getting 49 plus 32 is equal to 81. So since the discriminant is a positive number here, going back, if it's positive, there's going to be two unequal real solutions. So we're going to get two different real numbers as the solutions. And what's interesting here is actually because this is a perfect square, you could actually solve this very, very quickly and easily by factoring. All right, but so just to recap here, talking about these things, if you could solve by factoring, okay, going back real quick, if you can solve by factoring, that's the easiest method. Use the square root property, okay, when there's no x term, okay, when there's no x term, okay, you just have a squared term. Completing the square you can use, it's a little weird at first, take some practice, but the quadratic formula finally will always work. So if you're stuck and you don't know how to solve, you could just go boom right to the quadratic formula, and the quadratic formula will solve these quadratic equations for you every time.